The question is, the rank of the matrix 1 minus 1 0 0 0 0 0 1 minus 1 0 0 1 minus 1 0 0 minus 1 0 0 0 1 0 0 0 1 minus 1 5 by 5 matrix is. This question is from engineering mathematics. Topic is linear algebra. Subtopic is matrix algebra rank, which is from GATE 2017. The solution is, so let us denote the matrix is A, 5 by 5 matrix. 1 minus 1 3 zeros. Second row 0 0 1 minus 1 0. Third row 0 1 minus 1 0 0. Fourth row minus 1 3 zeros 1. Fifth row 0 0 0 1 minus 1. So reduce into row echelon form. It is the best method. So this is the first non-zero element. We should make its down element 0. That means we have to make this R4 minus 1 0 with the help of 1 R1. So applying the operation R4 plus R1 equivalent to only R4 changes. Remaining rows same, that is 1 minus 1 3 zeros, 2 zeros 1 minus 1 0, 0 1 minus 1 2 zeros, minus 1 plus 1 0, 0 plus minus 1 minus 1, 0 plus 0, 0 plus 0, 1 plus 0 1. Fifth row same, 0 0 0 1 minus 1. So in the second row, this is the first non-zero element. Okay, here 0 is a diagonal element and its down elements are some elements, some of the down elements are non-zero. If a diagonal element is 0 and it's one of the down elements is non-zero, just interchange row operations which will make diagonal element as non-zero, then proceed as above, that is below the diagonal we should make 0. Finally our aim is row echelon form, means elements below the diagonal 0. So here if I choose this is the first non-zero element, I can make its down element minus 1 0, but how can I make these two 0? So that's why here I am applying R2 interchanges R3, interchanging of two rows operation. R2 interchanges R3 equivalent to, so first row same, second row now 0 1 minus 1 2 zeros, third row 0 0 1 minus 1 0, fourth row same, fifth row same. Now as usual, the first non-zero element in the second row we have to make its down element 0, R4 element is down element with the help of R2, so the row operation correspondingly is R4 plus R2, only R4 changes, so which gives R1 same, 1 minus 1 3 zeros, R2 same, 0 1 minus 1 2 0, R3 is now 0 0 1 minus 1 0, R4 0 plus 0, minus 1 plus 1 0, 0 plus minus 1 minus 1, 0 plus 0 0, 1 plus 0 1. Now fifth row same, 0 0 0 1 minus 1. Coming to the third row, this is the first non-zero element. We have to make its down element 0, that is R4 element with the help of R3. Now applying R4 plus R3 equivalent to, this symbol stands for equivalent to. So equivalent matrix having same ranks. So only R4 changes, remaining rows same, 1 minus 1 3 zeros, 0 1 minus 0 0, 0 0 1 minus 0, 0 plus 0, 0 plus 0, minus 1 plus 1 0, 0 plus minus 1 minus 1, 1 plus 0 1. Next 0 0 0 1 minus, fifth row same. Now the first non-zero element in the fourth row is minus 1. We have to make its down element 0. So apply R5 with R4 row operation. That is R5 plus R4 equivalent to, so only R5 changes. Remaining rows same, which gives 1 minus 1 3 zeros, 0 1 minus 1 2 zeros, 0 0 1 minus 1 0, 0 0 0 minus 1 1, 0 plus 0, 0 plus 0, 0 plus 0, 1 plus minus 1, minus 1 plus 1. So the last row is a 0 row. Now first non-zero element in the first row, first non-zero element in the second row, first non-zero element in the third row, first non-zero element in the fourth row. So elements below the diagonal 0. Okay. So this is row echelon form. Therefore, rank of a matrix when the matrix is row echelon form is defined as number of non-zero rows, that is 4. Rank of a matrix is defined as number of non-zero rows provided the matrix is A. The matrix A is in row echelon form. That is elements below the diagonal 0. So the answer is 4. This is end of the question. The question is, the residues of a function f of z is equal to 1 by z minus 4 into z plus 1 whole cube are. ABCD options given. This question is from engineering mathematics. Topic is complex variables. Subtopic is residues, which is from GATE 2017. The solution is, so f of z is equal to 1 divided by z minus 4 into z plus 1 whole cube. Okay, so usually residues are at poles. That poles are obtained by equating denominator to 0 provided algebraic functions in numerator and denominator. So the poles of f of z are given by z minus 4 into z plus 1 cube is equal to 0. So that means z is equal to 4 comma 1. 4 is not repeated, so this is a simple pole, and this is pole of order 3. Order is generally denoted by number n. Okay, so simple pole means n is equal to 1, that is pole of order 1. So now calculate, that is residue is denoted by RES symbol of the function f of z at z is equal to 4. So it is a simple pole. The calculation of residue by the limits is limit z tends to 4 z minus 4 into f of z. So you know how to find the limits. This z minus 4 cancel with one of the factor will simplify to limit z tends to 4 1 upon z plus 1 whole cube. So this is exist by putting just z is equal to 4. 4 plus 1 whole cube is equal to 1 by 125. Okay, next, and residue f of z at z is equal to minus 1, because pole of order 3 means 1 by n minus 1 factorial, that is 3 minus 1 factorial 2 factorial, limit z tends to a, where a is pole, here minus 1, operated on d to the power n minus 1 by dz n minus 1, that is n minus 1 derivatives, where n is equal to 3, so simplifies to d square by dz square of z minus a whole power n, that is whole cube, into f of z. This is the procedure. So 1 by 2 limit z tends to minus 1 d square by dz square of this z plus 1 whole cube cancelled here will become 1 by z minus 4. So 1 by 2 limit z tends to minus 1, 1 by x derivative to minus 1 by x square, and minus 1 by x derivative to 2 by x cube, that is finally this is 2 by z minus 4 whole cube. So this simplifies to 1 by 1 minus 4 whole cube, 1 by minus 1 minus 4 whole cube, that is minus 1 by 125. Since d by dx of 1 by x is minus 1 by x square, d by dx of 1 by x square is minus 2 by x cube. Here, if z is equal to a is pole of order n, then residue f of z at z is equal to a is equal to 1 by n minus 1 factorial, limit z tends to a dn minus 1 by dz n minus 1 operated z minus a whole power n into f of z. This is the procedure we used. So finally the residues at the poles are 1 by 125 and minus 1 by 125. This is the answer, that is this one, this one. Accordingly, the option is B. This is the end of the question. General solution of the differential equation d square y by dx square plus 2 dy by dx minus 5y is equal to 0 in terms of arbitrary constants k1, k2 is. 4 options given. This question is from engineering mathematics. Topic is differential equations. Subtopic is higher order linear equation with constant quotients, which is from GATE 2017. The solution is, so the differential equation is usually denoted by DE, short form. D square y by dx square plus 2 dy by dx minus 5y is equal to 0. If you are interested, we can write that is operator form where d by dx is equal to capital D. So this becomes d square plus 2d minus 5 into y is equal to 0. This capital D is d by dx, which is comfortable for writing auxiliary equation. This is f of d. So auxiliary equation is obtained by putting d is equal to m. The next step to solve this higher order equation, A stands for auxiliary equation, m square plus 2m minus 5 is equal to 0. Quadratic equation, find the roots. Minus b plus or minus root over b square, that is minus plus 2 whole square, minus 4 into a into c, that is minus 5, divided by 2a, 2 into 1. So that is 2 square there. So this simplifies to 4 plus 20, 24. So I can take 4 common, so that minus 1 plus or minus root 5. 24 means 4 6 are 24. So under root is 6 and the denominator is cancelled. So this I can separate as minus 1 plus root 6 and minus 1 minus root 6. Okay. So two distinct real roots, different real roots. So according to auxiliary equation table, that is whenever right hand side 0, the solution is called complementary function, that is CF. So therefore two distinct roots. General solution stands for GS is y is equal to CF, where the independent variable is x, dependent variable is y. Y is solution, that is dependent variable. K1 into e to the power, generally we are denoting by this root, m1, m2. m1 first root, m2 second root. So e to the power m1x, that is minus 1 plus root 6 into x plus k2 into e to the power minus 1 minus root 6 into x. Okay. According to the options, you have to simplify here whether minus keeping outside or not. So this is the solution. Accordingly, the option is A. This is end of the question. The question is, the smaller angle in degrees between the planes x plus y plus z is equal to 1 and 2x minus y plus 2z is equal to 0 is. This question is from engineering mathematics. Topic is calculus coordinate geometry, which is from GATE 2017. The solution is, so here I am writing formula, angle between two planes whose equations a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0 is, say, theta. Then cos theta formula is a1 a2 plus b1 b2 plus c1 c2 divided by root over a1 square plus b1 square plus c1 square into root over a2 square plus b2 square plus c2 square. So now the planes, given planes x plus y plus z minus 1 is equal to 0 and other equation is 2x minus y plus 2z is equal to 0. Comparing with the notation a11, b11, c11, a22, b2 minus c22, d1, d2 constants. So implies cos theta is equal to 1 into 2 plus 1 into minus 1 plus 1 into 2 divided by root over 1 square plus 1 square plus 1 square into root over 2 square plus minus 1 whole square plus 2 square. So this is 3 by root 3 into 3 simplifies to 1 by root 3. Therefore, theta is equal to cos inverse. Put the calculator mode in degrees, the question related to degrees. So this is approximately 54.73 degrees. The power 0, small 0 indicates degrees. The question asked in degrees. So the answer is 54.73 degrees. This is end of the question. The question is, if the vector function f bar is equal to ax cap into 3y minus k1z plus ay cap into k2x minus 2z minus az cap into k3y plus z is irrotational, then the values of the constants k1, k2 and k3 respectively are ABCD options given. This question is from engineering mathematics. Topic is calculus. Subtopic is vector calculus, which is from GATE 2017. The solution is, so given vector field or vector function is 3y minus k1z into ax cap. Some people denote by I cap. This is magnetic field notations in EMT, plus k2x minus 2z into ay cap minus of k3y plus z. Z cap. So just ax, ay, az you can also denote for convenience purpose I, j, k respectively. So irrotational means related to curl procedure. So curl f bar, when curl f bar is 0, then the vector function is irrotational. So it is a 3 by 3 determinant. First row I, j, k, nothing but here ax, ay, az. Second row del by del x, that is dou by dou x, dou by dou y, dou by dou z. Third row comparing this ax coefficient, ay coefficient, az coefficient by f1, f2, f3, that is f1 I bar, f2 j bar, f3 k bar, we denote by a vector function f bar generally. So this is 3y minus k1z, k2x minus 2z minus k3y minus z. You know how to expand the determinant. Ax cap into, leaving first column first row, dou by dou y of this term. Partial derivative with respect to y means x constant, z constant. So minus k3 minus 0 minus dou by dou z of this term. That is derivative with respect to z partial means x term 0. So 0 minus 2z derivative with respect to z is 2, minus 2 into that is over minus ay cap into, deleting middle column first row, dou by dou x of this term. Partial derivative with respect to x means yz constant, simplifies to 0 minus dou by dou z of this term. Partial derivative with respect to z means y0, z derivative 1. So 0 minus k1 plus az cap into, deleting third column first row, dou by dou x of this term, x derivative 1, z is constant 0. So k2 minus 0 minus dou by dou y of this term, z is constant 0, 3y derivative 3. So this is given irrotational. Okay, so this simplifies to 2 minus k3 ax cap, and that is minus k1 ay cap, and that is k2 minus 3 into az cap. So f bar is irrotational given. Okay, implies curl is equal to 0. Curl f bar is equal to 0 cap. So 0 cap can be written as 0 into ax cap plus 0 into ay cap plus 0 into az cap. Equating like terms, you will be getting 2 minus k3 0 minus k1 0 k2 minus 3 0. Therefore k1 0, k2 3, k3 2. So the values of k1, k2, k3 respectively are 0, 3, 2. That is 0, 0.0, 3.0, 2.0. That is answer. Accordingly, the option is B. This is end of the question. The question is, the values of the integrals integral 0 to 1, integral 0 to 1 x minus y divided by x plus y whole cube dy dx, and integral 0 to 1, integral 0 to 1 x minus y divided by x plus y whole cube dx dy are A, B, C, D options given. This question is from engineering mathematics. Topic is calculus. Subtopic is double integrals, which is from GATE 2017. The solution is, so there are two types of double integrals given. Just according to one is with respect to x first, then with respect to y, or first with respect to y, then with respect to x. Many of the cases they are equal. When the function is discontinuous, generally these two type of double integrals are different answers. So let us see. The first case 0 to 1, inside 0 to 1, 1 by x plus y whole cube, numerator is x minus y. The first inside integration with respect to y, and the last with respect to x. So this can be written as, that means these are y limits 0 to 1, x limits also 0 to 1. 0 to 1, 0 to 1, I can write 2x minus of x plus y. X minus y can be adjusted or arranged into like this, 2x minus x minus 1, that is x minus y, divided by x plus y whole cube dy and then dx. Now this can be written as 0 to 1, integral 0 to 1, split into fractions. 2x divided by x plus y whole cube can be written as x plus y whole to the power minus 3, minus 1x plus y cancel, then simplifies to x plus y whole power minus 2. Both terms with respect to y first and then with respect to x. So with respect to y means the blue color terms, x terms constants. Okay. So next, integration x power n dx with respect to x is x to the power n plus 1 by n plus 1. But here we are doing with respect to y first, keeping x as constant. So this will give 2x into x plus y whole to the power minus 2 divided by minus 2 between the limits 0 to 1, minus of x plus y whole to the power minus 1 divided by minus 1 between the limits 0 to 1, and these two terms with respect to x finally between the limits 0 to 1. Since integral y to the power n dy is equal to y to the power n plus 1 divided by n plus 1 if n not equal to minus 1. So 2 minus 2 cancelled, then x into, this simplifies to, first substitute in place of y upper limit 1, then lower limit 0. So because to eliminate minus, so reverse y you substitute, first put y 0, this simplifies to 1 by x square minus 1 by x plus 1 whole square, and then this is dx between the limits 0 to 1. There is another term here, minus by minus plus, first put 1, that is 1 by x plus 1 minus 1 by x. Okay, these terms also, all these terms with respect to finally x. Okay. Now x into 1 by x square simplifies to 1 by x minus 1 by x cancels. So blue color terms cancelled, and the remaining, if I take LCM, x plus 1 whole square, this simplifies to minus x, and that simplifies to x plus 1 dx integral 0 to 1. Now finally this is 0 to 1, 1 by x plus 1 whole square. So this is x plus 1 whole power minus 1 by minus 1 between the limits 0 to 1. So this simplifies to 1 minus 1 by 2, that is half. Okay, that means 0.5. So, and what is the other one given? Integral 0 to 1, integral 0 to 1 x minus y divided by x plus y whole cube, first with respect to x and then with respect to y. So this can be written as 0 to 1, integral 0 to 1 x plus y minus 2y divided by x plus y whole cube, first x and then y. So x plus y minus 2y, that is nothing but x minus y. In this way, y added, subtracted, and added, x subtracted. So this is separate into terms, separate into fractions 0 to 1. integral 0 to 1. First term by denominator simplifies to x plus y whole to the power minus 2 minus 2y into x plus y whole to the power minus 3, both terms with respect to first x. Okay, and then dy. With respect to x means this blue color terms, y terms are constants. So just as above, you can repeat, that is 0 to 1. Take care. So that simplifies to minus 1 by x plus y between the limits 0 to 1 minus 2y into minus 1 by x plus y whole square with the 2. Okay, so these terms again between the limits 0 to 1 and then finally dy. So this simplifies to 0 to 1. In place of x we have to put, so 1 by y minus 1 by y plus 1 minus, here 2 cancelled, minus y into 1 by y square minus 1 by y plus 1 whole square, all these terms dy. So here plus 1 by y, this minus 1 by got cancelled, in the remaining just like you will be getting here. Okay, here plus and this is minus, so finally this is 0 to 1, taking LCM y plus 1 whole square, and this is minus of y plus 1, and that is minus into minus plus y dy. So here 0 to 1 minus 1 by y plus 1 whole square dy. So you will be getting x plus 1 by x cube minus 1 by 2x square. Okay, this is minus 2y minus into minus plus, so 2 cancel, y into 1 by y plus 1 minus this is, so here this is minus and this is plus, so finally here minus 1 by y plus 1 plus 1 by y minus into minus plus y into 1 by y plus 1 whole square minus, so this is better, you write plus, and that is, now in that case the 2 are cancelled, so minus y plus 1 plus y, so 1 by y plus 1, now this is integration is 1 by y plus 1 between the limits 0 to 1, so 1 by 2 minus 1, that is minus of, so the first one is plus 0.5, the second one is minus 0.5, so the two integrals values are 0.5 and minus 0.5 respectively. Accordingly the answer is option C. This is end of the question. Question is, passengers try repeatedly to get a seat reservation in any train running between two stations until they are successful. If there is 40% chance of getting reservation in any attempt by a passenger, then the average number of attempts and passengers need to make to get a seat reserved is dash. This question is from engineering mathematics. Topic is probability and statistics. Subtopic is random variables mean, which is from GATE 2017. The solution is, so here I can write, let small p is equal to probability of, PR stands for probability, getting reservation in any attempt, getting reservation in any single attempt, okay, which is given 40%. So that is nothing but 40 by 100, you can write 2 by 5 or 0.4, okay. So what is Q? Probability of not getting reservation. Is nothing but 3 by 5, that is 0.6, 60% chance, okay, not getting reservation. So the passengers try continuously until they are successful. Successful means to get a seat reservation. So let X be a random variable, denote the number of attempts, okay. By passenger to make a seat reserved, okay. So now X is equal to X and probability of X, this is the table. So if we attempt in 1, that means it will be getting a seat reserved whose chance is denoted by small p. If we do not get in the first attempt, he has to try next attempt, that is X takes 2 value. So the outcome is here QP. What is first Q? First attempt not reservation, second attempt getting reservation. If second time also not getting reservation, then he has to try third time. So first 2 times fail, Q into P. What does it mean, this Q? Failure, that is not getting reservation in that number of attempts. So continuous, this is unlimited trials, okay. So they are asking average number of attempts, therefore average number of attempts is nothing but expectation of X. This is a discrete random variable, summation X is equal to 1 to infinity X into P of X, okay. So here X is discrete RV stands for random variable. So X value 1, probability of 1, that is B of X, okay. P, X value 2, probability of that 2 attempts is QP, plus 3 into probability of 3 means 3 attempts, Q, P plus etc. In all this I can take P common, P into 1 plus 2Q plus 3Q square plus so on. This is a Taylor series Maclaurin series expansion where Q lies between -1 to 1. So since 1 plus 2x plus 3x square plus binomial expansions or standard Maclaurin series expansion, 1 minus x whole to the power -2 if -1 less than x less than 1. In place of x we have Q value lies between -1 to 1, okay. So this is P into 1 minus Q whole to the power -2. So finally this simplifies, Q value 2 by 5 into 1 minus Q, 1 minus 3 by 5 is 2 by 5, whole power -2 means 5 by 2 whole square. 1 2 by 5, 5 by 2 cancel, 5 by 2, so 2.5 on an average 2.5 attempts. So the answer is 2.5. This is end of the question. The question is, an integral I over a counterclockwise circle C is given by I is equal to integral over C z square minus 1 by z square plus 1 into e to the power z dz. If C is defined as mod z is equal to 3, then the value of I is ABCD options given. This question is from engineering mathematics. Topic is complex variable. Subtopic is complex integration, which is from GATE 2017. The solution is, so line integral problems, first step is curve equation. C is mod z is equal to 3. That is radius E, center 0, circle. So denominator of the integrand z square plus 1 is equal to 0 implies z square equal to -1, z is equal to plus or minus root -1, that is minus I comma I are the singular points SP, and both if I put here mod I mod minus I here less than 3, comma both lies inside C since mod I value 1. Okay, and these are also simple poles. Also Z is equal to minus I comma I, they are not repeated or simple poles, implies pole of order 1. So in some problems whose integral values along a closure curve is easily evaluated by residue theorem, some other problems Cauchy integral theorem or Cauchy integral formula. Okay, so residue f of z at z is equal to minus I, this is simple pole. So when it is a simple pole, how do you calculate residue at z is equal to a? Limit z tends to a, z minus a into f of z. A is minus a, z tends to minus I, z minus of minus I is z plus I into f of z. Already denominator z square plus 1 can be written as z plus I into z minus I. So here f of z is nothing but z square minus 1 by integrand function into e to the power z. This is the integrand. Okay, so this z square plus I denominator have factors. One is z plus I, is z minus I. A plus b into a minus b is a square minus b square. I square value minus 1, you know that. So this is limit z tends to minus I. This z plus I cancelled here. Remaining terms z square minus 1 by z minus I into e to the power z. In all the remaining terms put z tends to minus I. So minus I whole square minus 1 divided by minus I into e to the power minus I square value minus 1. So minus 2 by minus 2I, that is 1 by I, simplifies to minus I into e to the power minus I. Okay, or e to the power minus I by I, whatever you want. And other residue f of z at z is equal to I. Residue denoted by RES symbol. Okay, is equal to, it is also simple pole. So limit z tends to I, z minus I into f of z. So once again this z minus I cancel with one of the factor of the denominator of f of z, which simplifies to limit z tends to I, numerator same, z square minus 1 divided by z plus I into e to the power z. So this is I square minus 1 divided by I plus I into e to the power I. Now I square value minus 1, 2 cancel. So this is minus e to the power I by I. So therefore by Cauchy's residue theorem, comma integral over C f of z dz is equal to 2 pi I into sum of the residues at the poles f of z, residue f of z at z is equal to minus I plus residue f of z at z is equal to I. So here the outside I cancel with, after summing, after adding the 2 will simplify to 2 pi into e to the power minus I minus e to the power I. So since sine theta is equal to e to the power I theta minus e to the power minus I theta by 2I. So now this I can write minus 2 pi, take common minus, take out minus, this can be written as minus 2 pi into e to the power I minus e to the power minus I, where comparing with theta 1 degree or 1 radian. So minus 2 pi into 2I sine 1. Okay, so finally this simplifies to minus 4 pi I into sine 1, where I value root over minus 1. So the answer is minus 4 pi I sine 1. Accordingly, the option is D. This is end of the question. The question is the minimum value of the function f of x is equal to 1 by 3 x into x square minus 3 in the interval minus 100 less than or equal to x less than or equal to 100 occurs at x is equal to. This question is from engineering mathematics. Topic is calculus. Subtopic is maxima minima, which is from GATE 2017. The solution is, so f of x given x by 3, that is multiply x cube by 3 minus that given fx can be written as x in closed interval minus 100 comma 100. So that means a value minus 100, b value 100. This is actually absolute or global maximum minima. Whenever maxima minima related in the closed interval, that is called absolute or global maximum minima procedure. So find first local maximum minimas, then that closed interval maximum minima is nothing but maximum of all local maximum values, comma f of a, f of b. Minimum of a given function in the closed interval is nothing but minimum of all local minimum values, comma fa, comma fb. So first find f of minus 100. So this is minus 100 cube, you know that is divided by 3 minus 100. Later you simplify f of 100 cube 100 6 zeros by 3 minus 100. Okay, now f dash x equal to 0 for obtaining stationary points, that is x square, x cube derivative 3x square with respect to x minus 1 equal to 0. Solving minus 1 comma 1. So both belongs to closed interval minus 100 comma. This is the important step, whether we check that belongs to the interval or outside the interval, that is the step care to be taken. Both are belongs to. So are stationary points. Now in both cases you have to find f of minus 1 and that is f double dash x is equal to 2x. So at x is equal to minus 1 comma f double dash x is minus 2 less than 0, which gives fx has local second derivative less than 0 means local maximum. Okay, at x is equal to 1 comma f double dash x, that is second derivative, becomes plus 2 greater than 0. When second derivative less than 0, that function has local minimum at that point. The question related to minimum value, so this to be considered, and this function. So therefore minimum value of f of x is nothing but in closed interval minus 100 comma 100 is nothing but minimum of f of minus 100 comma f of 100 comma local minimum value. So what is local minimum value we got here, and local minimum value is the function at that x equal to 1, that is f of 1, which is nothing but in the function put x equal to 1, 3 minus 1 simplifies to minus 2 by 3. So this is minus 2 by 3, and here options not provided. This is numeric question, so you have to calculate the terms. In this case this simplifies to minus 333,433 in this case plus 333,233.33. Okay, so and minus 2 by 3 is nothing but minus 0.6 continuously, that means 7 you can write. So which of these minimum, this is a bigger quantity, then positive quantity is greater than negative quantities. This is a, in negative quantities bigger number is become small number. Okay, so here minus 0.667 is greater than minus 433.3. So you will be getting occurs at x equal to, so is nothing but minimum value of f of x in closed interval minus 100 comma 100 is f of minus 100 and it occurs at x is equal to minus 100 only. This is okay. Because this is the minimum value. So the minimum value of the function, they are not asked the minimum value, but to decide minimum value we have to simplify these values. That is why they ask directly occurs means the position of x. So at x equal to minus 100 you have the minimum value of this condition. So the answer is minus 100. This is end of the question.